Hello students, welcome to experiencetutor.com. Today's lesson is class 12th chemistry solid state part 1.
Let us start with the welcome message. Dear students, welcome to our channel experiencetutor.com. In this channel, we will teach physics, chemistry, mathematics and biology for the students of class 10th, 11th and 12th and those who are appearing for the school board examinations and entrance examinations like IIT, NEET and all state level engineering and medical examinations. This course is organized according to different topics for each subject. Therefore, it contains separate video for each and individual topics. Hence, it covers complete syllabus for CBSE, ICSE, ISC and all the state board examinations and engineering and medical examinations. You can also find the relevant topics from foreign school examinations like SAT, IGCSE, IB, etc. Enjoy your learning. Thank you.
Let us start with the states of matter. There are 5 states of matter: solid, liquid, gas, plasma and BEC, Bose-Einstein condensate. What is solid state chemistry? Solid state chemistry is the study of structure of solid and their properties. There are 2 types of solids. First, crystalline solid, then amorphous solid. We'll learn more detail about this too, but for now, just we should know about crystalline solids. In crystalline solids, arrangement of atoms or ions are systematic. Most of the solid substance are crystalline, such a way that metal like copper, iron, silver, etc., non-metal like phosphorus, sulfur, etc., beside this, etc., are crystalline solids. Beside this, compounds like sodium chloride, potassium chloride are also crystalline solids. Molecular solids like naphthalene is also a crystalline solid. Classification of solid substances on the basis of intermolecular attraction forces. First, molecular solids. Second, ionic solids. Third, metallic solid and covalent solids. Now we'll study in detail about these solids. First, molecular solids. Molecular solids present in molecular solids present in the molecular solids are as a constituent particle. Molecules present in the molecular solids as its constituent particles. Molecular solid can be classified into 3 parts. Part A, non-polar molecular solids. Part B, polar molecular solids, Part C, molecular solids containing hydrogen bond. Now let us study in detail about this. First is non-polar molecular solids. Elements like argon, helium and molecules formed by non-polar covalent bonds. Elements like dihydrogen, dichlorine, diiodine, etc. can be included in this type of solids. The atoms or molecules in this type of solid possess the weak dispersion force or London forces. Solid of this type possess low melting points and they are soft and non-conductor of electricity. At normal temperature and pressure, they are in liquid or gaseous state. B. Polar molecular solids. The solids like sulfur dioxide, SO2, etc. generally possess polar covalent bond. The molecules of such solids are bound by relatively strong polar-polar interaction. They are also soft and non-conductor of electricity. Their melting points are higher than those of non-polar molecular solids. Even then, they are in gaseous or liquid state at normal temperature. Solid SO2 and solid NH3 are solids of this type. Third is molecular solids containing hydrogen bond. In this type of solids, atoms like hydrogen form polar covalent bond by combining with electronegative atoms like fluorine, oxygen or nitrogen. The strong hydrogen bond in them keep them in bound state. Substance like ice is the example of this type. They are also non-conductor of electricity. At room temperature and pressure, they are volatile liquids of soft solid. In the molecule of ice, 4 molecules of water are attached by hydrogen bond. It gets separated from hydrides of other elements of the same group because of hydrogen bond. Next type of solid is ionic solid. The constituent particle of ionic solids are ions. The cations and anions of such substances are attracted by strong Coulombian force and so they possess forced molecules in three-dimensional direction. They are hard and brittle. Their melting points and boiling points are higher because of strong attraction between positive and negative ions in the solids. Though ions are present in such substances, even then they do not conduct heat or electricity because they are bound by strong attraction forces between positive and negative ions. But if they are dissolved in water or are melted in a solid state, then their ions are separated and so conduct electricity. The third type of solid is metallic solids. Most of the metals are in solid state and so metal possesses positively charged nucleus around its which free electrons are arranged. Then they are arranged in a systematic way. Electrons are spread in the form of electron C around the nucleus of atom of the metal. These electrons do not remain confined to any nucleus but are moving around the nuclei like the flow of water in the sea. And these free electrons allow electricity and heat to conduct. When electricity is applied, they move, but in the new situation, electron makes its arrangement around the nuclei. When heat is supplied to the metal, the thermal energy is spread everywhere by the free electron. In addition, metals have luster and in some cases have colors. This is due to the presence of free electron. They are ductile and malleable. Fourth type of substance is covalent solids. In the whole crystal, the adjoining atoms form covalent bonds in larger proportion, and so it results into different crystalline solids. They are called giant molecules. Many diversity are found in these compounds. They possess covalent bonds directional properties. Their molecules are bound tightly and hence they possess very high boiling points. Some decompose before being melted. They are not conductor of electricity. Diamond and graphite are the example of this type. Diamond is a soft and good conductor of electricity because of its structure is specific. 3 atoms of carbon in graphite form covalent bonds by sp2 hybridization, and the 4th electron remains free. It keeps one layer of graphite combined with other layer. These layers thus consisting of a hexagonal structure having sp2 hybridization and formed in graphite, and 4th electron kept at a distance of 340 picometer between the layers, and it conducts electricity because it is free. The different layers of graphite can move, creating friction with each other, and so graphite is a good solid lubricant. In contrast to this, tetrahedral structure is formed by sp3 hybridization in diamond, and all the 4 corners are combined with other carbon atom of diamond and spread in 3 dimensions. Hence, it is very hard. It cannot conduct electricity because no free electrons are there. Thus, it can be seen that 2 allotropes of same element, if intermolecular force and hybridization form are different, there is a great change in their properties. Now we'll go through a table which tells clearly about the differences of these solids. First column is type of solid, second column is constituent particle, third is attraction forces, fourth is example, fifth column is physical nature, sixth column is melting point, seventh column is electrical conductivity. Molecular solids. Molecular solids constituent particle are molecules. Attraction force are dispersion or London forces. Example are ArCCl4 H2I2 CO2. Physical nature soft. Melting point very low. Electrical conductivity non-conductor. B. Polar. Constituent particles are molecules. Attraction forces are HCl. Attraction forces are dipole inter-attraction. Examples are HCl, SO2 and H3. Physical nature is soft, melting point is low, electricity conductor of electricity is non-conductor of electricity. C. Third one, the hydrogen bond possessing. Molecules, constituent particle molecules. Attention forces, hydrogen bond. Attraction forces is hydrogen bond. Example H2O. Physical nature hard, melting point low. Second type of solid is ionic solid. Here the constituent particle are ions. Attraction forces Coulombic or electrostatic forces. Example NaCl, MgO, ZnS, CaF2. Physical nature hard, melting point high. Electrical conductivity solid state non-conductor of electricity, but molten or aqueous solution are conductor of electricity. Third, metallic solids. Constituent particles positive ion in C of a delocalized electrons. Attraction forces metallic bond. Example FeCa, Mg, Ag. Physical nature hard but ductile and malleable. Melting point comparatively low, comparatively very high. Electric conductivity, conductors in solid and molten states. Fourth type of solid is covalent or network solid. Constituent particle are atoms. Attraction forces, covalent bond. Example SO2 quartz, SiC carbo random, C diamond, C graphite. Physical nature hard, melting point very high. Electrical conductivity non-conductor of electricity in solid state, but graphite is a conductor of electricity, but diamond is not.
And this is the end of this topic. If you like this video, please subscribe our channel and give us a like sign. Please click on the bell icon so that you get automatic notification when a new video is uploaded by us. Thank you for watching our channel.